Hey everybody, today we're going to run through conducting a megger test. Um, so first things first, you want to make sure all your, you have your conductors all isolated, separated, not in contact with anyone or anything. We've got some fairly dangerous voltage going to be running through it, so we don't want to hurt anyone. So that's, our first and foremost, got to be safe about it. After that, let's just kind of dive in. We're going to be using the Fluke 1507 insulation tester. Um, there's a couple other models. I believe like the 1587. I believe we also have one of those. Works very, very similar. I do like this one just because it's a little, pretty straightforward and simple. So for basically to get started, you're going to select a voltage that's going to be the output voltage on the megger that it'll put through the conductors. In today's example, we're going to call this a 208 three-phase circuit. So in that case, we're going to test it at 500 volts. If we were going with 480 or 277, the test would be done on 1,000 volts. So for today, we're at 500, and let's go ahead and just dive right in. So kind of the megger test report kind of spells out the order, that you can go ahead and just follow, going right through, testing each conductor. So we'll just get started, kind of just based right off of that. So we're going to go phase A to phase B first, and hit lock, and then test, and that's going to put voltage into the cable and give us a resistance reading. In this case, that's 550 megohms, which for this particular meter is the max that it'll go on the 500 volt setting. So that means that's a perfect result, exactly what we want. So phase A to B, 550 megohms, good to go. Now you'll notice this red light that's on, that indicates that this is putting out voltage. So these leads are not safe to touch if that red light's on. You can just hit either lock or test, and that'll make it stop the test. Voltage is dissipated. Now we're good to go. So next we're going to go A to C. Same thing, lock, test, and again that one looks good. So we can go ahead and log that result and move on to the next one. So now we're going to go B to C, be our next test. Same thing. Again, 550 megohms, exactly what we want. So we'll go ahead and call that one. Now I will say, normally you want to do this for 1 minute on each test as kind of a standard. Today we'll go ahead and just run through them a little faster. Plus these are super short cables, so there's not going to be a lot of waiting for it to fluctuate or any of that. But typically you want to run this test for 1 minute. Okay, so moving on, we're going to go neutral to phase A. Test that. Again, perfect, 550. So we'll just log that and move on. Now we're going to go neutral to B phase. Same thing, guys. There we go. 550 again. Looking good. Now we're going to go neutral to C phase. Do the same thing. And there we go. You can see how fast that pops up, gets that reading real quick in this short of a run. But yeah, so we'll log that and move on. So next we're going to do our ground to phase A. And we'll start. Again, perfect test. Looks great. All right. And we'll move right along to phase B. Do that one. Okay. Yep, that looks good. All right, so we'll log that again, 550 megohms. Now Now ground to C phase, and that should be our last test for this this set of conductors. Okay, we're all set. Looks great. Everything passed on that, so this one's a pass. We are good to go. So that set is ready to go, be put into service, landed, energized, good to go. Okay, so for our second one here, I actually went ahead and damaged the cable a little bit, and these are actually sitting in a little bit of water as well, just to kind of simulate conductors in an underground conduit, you know, maybe that has some water in it. So we'll go ahead and just get started on this one. Same exact procedure. Phase A to phase B. Test. And between those two phases, we got no problems. 550 megohms, 527 voltage, everything looks good. So we'll go ahead and log that. Now we go A to C. Do the same thing. And again, right there, 550 megohms. Everything looks great. So we can go ahead and log that one. All right, now we are going to go from B to C. Let's test that. Okay, now we finally have a little different result. So that's only 0.05 megohms, only getting us up to 90. Yeah, it's still moving around a little bit, but you guys can see that definitely this is a much lower value. This is definitely a fail. The bare minimum we want to see on any of these is 10 megohms, and really it should be over 50 on pretty much anything, especially anything new installed. Should be over 50 or over 100 really. Yeah, so obviously we have an issue with this one, so we're going to go ahead and document that, log it at that value, and we'll move on now. Now we're going to go neutral to phase A. Go ahead and test that. Okay, that one looks good. Doesn't look like we have any issue in that with that conductor. So go ahead and log that. Now we're going to go neutral to phase B. Same thing. Again, that one's looking good. So between those two conductors, doesn't seem to be any major issue there. So we'll go ahead and log that, 550, and we will move on. Now neutral to C phase, same thing. And again, looking pretty good, 550. Doesn't look like there's a major issue there. So we'll go ahead and log that, and we'll move along to the next test. Last set we'll do is ground to each of the phase conductors. So ground to phase A, 550 megohms again, looks good. No issues. All right, go ahead and log that and move to the next. So now we got ground to phase B. And again, there we go. Now we're seeing our problem show up again. So again, here we'd let the test run for a minute, log whatever the final value is, you know, wherever it kind of settles. Obviously, this one's again a fail, big time. Okay, and then we'll do ground to phase C. And there we go. And again, that one as well we have an issue with. So so we want to go ahead and just log that how it shows, and that is also going to be a fail. All right, so with that, we can see that between ground and phase B and C, we have an issue, and then also directly between phases B and C, there's an issue. And so if we open that up and investigate, what we'll actually find is that there's nick in phase B and in phase C, and and with the water that's inside the cable now that's gotten its way in, it's creating a short, or creating a pathway between them, and that's why we're getting those bad readings. Hope this was fairly informative for everybody. Yeah, thank you guys. Appreciate it.